So the next parameter that we are going to talk about is what we call as H parameters. As I mentioned, it's popularly used in transistors. And if you go back and revisit your second year, I'm sure that you would have plugged your transistor in a multimeter and you would have calculated the beta value or HFE of a transistor, and if it is high, you will say that the transistor is working or not. So that's a very famous parameter in transistors. We call it as H parameters. So how do we have H parameters? H parameters, we will have V1 I2 is equal to H11, H12, H21, H22 and I1, V2. So if you expand this, I'll have V1 is equal to H11, I1 plus H12, V2, and then I2 is equal to H21, I1 plus H22, V2. H22, V2. Suppose we need H11, we will make V2 go to 0. So I will have H11 is equal to V1 by I1, and what is the condition? V2 is equal to 0. What is this? In a transistor, V1 by I1, it is nothing but input impedance of your transistor. Input impedance of, let's write it, transistor, also known as HIE. I use the word E because it's an emitter follower. So I popularly use it. It's a popularly used transistor. So so I call it as HIE. And next is H21 will be nothing but I2 by I1, which is when condition V2 is equal to 0. We also call it as forward current gain, also called as forward current gain. So H, if we need the right fellows, H12 will be equal to V1 by V2, and what is the condition? You'll have I1 to go to 0, yes. So when I1 is equal to 0, which means this is nothing but your V1 by V2, which means reverse voltage gain, or this is also called as HRE, and this is your HFE. This is your HFE, also called as beta, the forward gain of your transistor. So H12 is V1 by V2, and the last fellow will be H22, will be nothing but I2 by V2 when I1 goes to 0. This is nothing but your output admittance. Output admittance, HOE. Output admittance, a very popular parameter used to characterize a transistor. So this is your H parameters. In our next class, we will be talking in detail about ABCD parameters.